Here we go, part 2 of methods. Wish me luck. There's a lot on the agenda. We have activation records, passing arguments by value, modularizing code, method overloading, ambiguous invocation, and even the scope of local variables. So starting right off the bat, what is an activation record? Each time a method is called, the system creates what is called an activation record, which stores all of the parameters and all of the variables for that particular method. That activation record is then placed in an area of memory called the stack. We're going to see later we have two areas of memory. We have the stack memory and we have the heap memory. For now, we're looking at the stack. And what is this stack memory? We literally visualize it as a vertical stack where more and more activation records are placed onto this stack. So as an example, when method main calls method A, and then method A calls method B, the activation record for method A is kept intact. A new activation record for method B is then created, and this new method B, it was created for this new method B that was just called. And then when method B finishes its work, it's going to be removed from the stack and we return to method A. And that's a lot of words, method A, method B, return from the stack. Let's see an example and let's draw it out and make sense of it. So I'm going to go over to NetBeans, and I have here an example open where we see two methods, method A and method B, and we also have our traditional method main. So what's going on with this? We have here our method main, and inside that method I merely print inside the main method, and then I call method A. Well, what's going on inside method A? Well, here's method A. We merely print inside the method A method, and then from method A we call method B. And if you look at method B, we merely print, hey, we're here inside method B. So when I run this code, this is what I get. It says inside the main method, to be expected because we started at main, we're printing this. We then call method A. We come up here to method A, which executes this print statement, and it says inside the method A method. Then we call method B, and we come to method B, which has one line, and we execute that statement inside the method B method. So how does this relate to activation records, and what would we really see on this stack? So here, imagine we have this vertical stack, and it's literally called a stack. This is your stack memory. When we first call method main, what happens is main gets an activation record on this stack. And any variables that are needed for main, if we had made variables, for example, if I come back to the code, and if I type, bear with me, and if I type right here, int x equals 3, int y equals 4, hypothetically, how will that affect our activation record? On this activation record, we're going to have right here, x equals 3, and y equals 4. This activation record is used to store all of the variables and the parameters and even the method calls that are used to call other methods that will then open up on the stack as well. So notice in our code, after we printed inside the main method, what happened? We then called method A. Well, what happens when we call method A is a new activation record opens up. And we now have method A right here. Now method A is an activation record on the stack. There's nothing really happening inside method A. There's no variables to be saved, but if there were, they would be saved right here. And then method A, what did it do? It called method B. And so here we have method B on the stack. And again, there's no variables really for method B. But this is what happens. We now have three individual activation records. And once method B finishes execution, it's removed from the stack, and we then go back to method A. Once method A finishes its execution, the activation record for method A is removed from the stack, And then finally, we come back to method main. And once main finishes, its activation record is removed from the stack, and now the stack is empty and the program has completed. So in a nutshell, that is the idea of an activation record. And we'll see why that's valuable on several examples here in these slides. But here's the first one that we saw last time when we're trying to determine the maximum of two numbers, and we wrote this method max. So if we simply follow this animation, in our main, we have a main activation record here. We have this variable I equals 5, j equals 2, and now we have k equals, but we can't assign k anything yet, because notice on the right side of this assignment, we're calling method max. So when we call method max, now we have a new activation record. And what did we send to method max? We sent over the values for I and j, which were 5 and 2 respectively. Now in method main, those values were saved inside the variables I and j. But now inside this new method, this new activation record, those two values are sent over as parameters, and they're being saved inside the variables num1 and num2 respectively, these formal parameters here. We then determine the result. We have this variable result that we declare, and we determine that result is in fact going to be 5, and we return result. Where does result get returned? Result gets returned into k, and then we print it. We saw this example quite exhaustively last time. But the takeaway here is now to understand these activation records that open up on the stack. So once method max returns the result, that activation record is removed from the stack. Now we're back at main, program control has returned to main, and we make this print statement. Now that last example was with animation, but here's just a single image to see what's going on with these activation records. Here's the activation record for main. Main then calls max. We have the activation record for max open on the stack. We determine which is the maximum. We get that result as 5. It's returned, which means that activation record for method max is removed from the stack. We then go back to main. We finish processing the main method. Once the main method has completed, that activation record for main is finally removed from the stack, and then the program has completed. Passing arguments by values. The power of a method, as we know, is when we start sending over arguments, parameters, those are synonyms, to our methods. These parameters must be given in the same order as the formal parameters within the method signature. This is known as parameter order association. Here's an example. We know that print line method, it works by taking in a string parameter, and that it then prints that string to the console. That's just an example. But what if we want to write a new print line method that not only has one parameter, but has two parameters? The first parameter could be a string, a message we would like to print. And the second parameter would be an integer representing the number of times that we would like to print that particular message. Seems kind of silly, but it's a good example to talk about the order of these parameters and the necessity of matching up the actual parameters with the formal parameters. And so we have this new method that we're creating. It's not called print line. Instead, it's called nPrintLine, where n stands for this parameter n here, which represents the number of times we would like to print this particular message. And so now if you look at the code, we have a for loop. We loop from 0 to less than n. So if n was 3, we would loop from 0, I is 0 to I is 1, and then I is 2. We're going to loop 3 times, and we're merely going to print out this message 3 times. Pretty straightforward. So what happens if we call this method nPrintLn with these two parameters, the string hello, and then the second parameter, the number 3. Of course, we're going to print the string hello 3 times. Again, pretty straightforward. The string parameter hello is passed as an actual parameter, and it's saved into this formal parameter message. The value 3 right here, the actual parameter 3, is saved into this formal parameter n, and then again we execute that for loop and we print hello 3 times. How would we print computer science? 100 times. We would simply send over computer science as a string, as that first actual parameter, and we send over as the second actual parameter 100 to then print it 100 times. But consider the following. And maybe this is clear, but it's very important. What if we had reversed those two parameters? What if we sent over 100 followed by computer science? Well, the problem is that we have to match up the data types. Their order has to matter and their data types have to matter. So 100 is an integer. Clearly, we can't send an integer and save it over here into the formal parameter string. And this second parameter, which is a string, clearly can't be saved into this formal second parameter, which is an integer. So just an important reminder that the parameters, they have to match with respect to their quantity. If you have 2 formal parameters, you need 2 actual parameters. If your 2 actual parameters are a string followed by an integer, well then you better be sure that the method signature is expecting 2 parameters, a string, followed by an integer. That's the takeaway of this particular example. So the arguments, they must match. The actual parameters, they must match the formal parameters with respect to the quantity, meaning the number of the parameters, the order of those parameters, and again, the compatibility of those parameters. So compatibility means that you can pass the argument to the parameter without causing an error and without having to do explicit casting. As an example, we can send an integer actual parameter to a double formal parameter, right? Because an integer can in fact be saved inside a double. And we've seen this. If I were to just type here within this particular program, I'll come to garbage. If I make double x, I can save into that 4 because that 4 will implicitly get casted into a double. I don't need to put this explicit cast that I just typed. That's an explicit casting. I'm explicitly telling Java, take this 4, make it into a double 4.0, and then save it into X. I don't need to do that. It happens automatically. It happens implicitly. So if you have a particular method that is expecting a double, we can send it to it a double, but we can also send to it an integer, no harm, no foul. But you have to make sure that all of these passing of arguments from the actual parameters to the formal parameters can happen without explicit casting, otherwise an error would occur. So when you invoke a method with a particular argument, the value of that argument is what is actually sent to the method. This is called pass by value. So even if the argument is a variable, the value of that variable is what is actually passed and saved into the formal parameter. The variable itself is not actually affected regardless of any changes you make inside the method. And there's several famous examples that are shown almost in every textbook. We'll look at 2 of them. Here is an increment example. So as an example, increment example, look at our main here. In our main, I'm zooming way in so you can see this clearly. Let me come over here. So in our main, we have this int variable x, which is of data type int, and we save a 2 inside it. We merely print before a call x is, and of course x is 2. We then call this method. So let's go look at this method. We have here an increment method. This increment method, it takes a single parameter x. And what does it do? It merely increments that particular parameter, that variable x, hence the name increment. And then we have this print statement. We say printf inside the method, and after incrementing, x is this value. So it's pretty straightforward. The increment method, we take a parameter, we increment it, and then we print that particular result. So with that in mind, now take a look back at this main method. We have x is 2, We print before the call x is, we print 2, we call the increment method, we execute this increment method, and then we come back here after the call x is what? And what are we going to get? So if you had never seen this before, and we've seen this in Python, you would expect that, hey, x is 2, before the call, it'll print x is 2. We come to the increment method, x is clearly going to become 3, which is true. Inside the method, and after incrementing, x is 3. That's what we expect. Once that method shuts down, we come back and we print this after the call. We would expect x is 3 if we had not already seen this. But we have seen this, so most of you are probably expecting, you know what, yeah, after the call, x is 2, and that's not surprising to you. That's not shocking to you. But what's actually going on is this. We have here, and I want a little bit more space, so let me erase this. So I'm going to draw that stack again. Here's our stack, making it a little bit wider. This is our main method. We have an activation record. Our main method, we had x equals 2. Then, and we printed it. We said before the call, x is 2, and we printed it. Then we called the increment method, so we get a new activation record. Here's this increment method, right? And in this method, what did we do? We sent over x, so x was 2. We then incremented it, so x became 3, and we printed it. And we printed inside the method after incrementing x is 3. We printed it. But once we printed it and the method shut down, all of this right here is going to erase and it's going to shut down. Inside main, what is x? X is still 2. So when this finishes, that method finishes, and that activation record gets removed from the stack and we go back to main, well, what is x? X is still 2. And that's the takeaway from this particular problem and why it's important to understand how activation records, what they are and how they work. So here, even though we incremented x, this is a local variable, local to this particular method. And so we sent over this value 2. This value 2 came right here, right? It was sent over as an actual parameter, got saved into this formal parameter, into that spot right here, and then we increment it. But the takeaway is that this x right here that I'm highlighting on line 4, which is coming from this formal parameter, that is a different value than this x. That's the takeaway. Those are 2 different values. Now, I gave it the same name, but I could have called it something else. I could have said b and make this b, and then make this b right here, and then b right here. And that would be less confusing because people would expect, yeah, this is x. And of course, when I then call it, I can see inside the method after incrementing b is 3, but sure, x is still 2, which would be clear because you'd realize, well, this is x is 2, and this is a different thing. That's b. But no, but even if it's the same exact name, it's important to know that these are 2 different variables. This variable is local to the main method, and this variable right here, this parameter, is a new local variable that belongs strictly to the increment method. So that's a classical example. Another example is swapping 2 values. We've seen how to swap 2 values using a third variable temp, but what if we want to write a method to swap 2 values? A method. So in that method, we swap them, and make no doubt about it, they will swap. But when we look at our main after calling the method, it might surprise us that, wait, those variables are in fact not swapped. And it's a bit confusing at first. So when we come back here, let's look at the swap example, and let's pull up just the swap component here. I say inside the swap method, this is our swap method. Inside the swap method, before swapping, we merely print num1 is blank and num2 is blank. And I'm printing those 2 parameters. That's before swapping. Now I swap using the famous 3 lines of swapping. We've covered that extensively. And then in this method, after swapping, we print. After swapping, num1 is blank and num2 is blank, and be sure they swap. So now let's look at our main. We have num1 is 3, num2 is 7. I print before calling the swap method, Num1 is 3 and num2 is 7. Cool. We then call the swap method. We come up here and we do what we just discussed. After calling the swap method, we then print again. After invoking the swap, num1 is blank and num2 is blank. Let's run the code and see if we get what we are expecting. So before invoking swap, num1 is 3 and num2 is 7. Of course, that should make perfect sense. Now we call the swap method. So now we're coming up here to the swap method, and we have two print statements. It says inside the swap method. Perfect. Before swapping, num1 is blank and num2 is blank. Yes, num1 is 3 and num2 is 7, as we expected, right? Because we sent over, this was a 3, this was a 7, right? That 3 and 7 they were sent up here. That became a 3, that became a 7, right? Pretty straightforward. So inside the swap, before swapping, num1 is 3, num2 is 7. We then perform a swap. And what do we have? We say after swapping, num1 is now 7 and num2 is 3. That's what we expect. The only part of this that's confusing the first time you see it is after invoking the swap method. Once the swap method has concluded and we see that num1 and num2, they swapped. There's no doubt about it. No doubt about it. They swapped. But yet in main, after the swap method, num1 is still 3 and num2 is still 7. Why is that? That's because of the activation records and to understand what is going on. So here, I'm going to clear this out, and we look at this. We have our main method. This is our main. And in our main, we had, I'm going to call it num1 was 3. We had num2. It was 7. We then called swap. And we sent to swap 3 and 7. Right? Let's come up here to the swap method. I'll write it in black. We're at the swap method. This is a new activation record. Swap, and we sent over 3 and 7. And now, num1 is 3, and num2 is 7. Because those were the names of those two parameters, right? This parameter here was num1, and this formal parameter here was num2, right? So we have num1 is 3, we have num2 is 7. We then swapped them, and the result of the swap is what? That num1 becomes 7, and num2 becomes 3. That's exactly what we get. That is the result, the expected result of the swap, and in fact, that's what we see in our output. Num1 is 7, and num2 is 3, right? That's what we expect. But I want to be very clear that this num1 and num2, those two variables are different than these two variables. That's the takeaway. Even though they're different, even though it's the exact same variable name, they are different variables because these two variables here are defined within main or declared within main. These two variables here, they are declared within a different method. It's the swap method. It's a different activation record. So they are two different sets of variables. And so even though we swapped num1 and num2 up here, this num1 and num2 never changed, right? And so after swapping within the swap method, once this activation record shuts down because the method finishes, and we come back to main, we see that in fact, in main, num1 is still 3 and num2 is still 7. A very famous example, classic example shown in every textbook to understand the idea of passing argument by values. We only sent over the value 3, the value 7. We didn't actually touch the variables inside main, which meant as a result that num1 in main, that num2 in main, they don't actually swap, even though we swapped the values within the swap method. num1 and num2 in main are still what they were before invoking that swap method. Very important example. And this is just more discussions of this. Common question. In this example, the variable names were different. When we look at the formal and actual parameters, would it make a difference if the name were the same? The reason why that example was there is because I actually edited this code to make it where the name was the same. So hypothetically, again, if we were to have made this num1 up here, make this just x, and then make this num2 y, now I think most readers would immediately understand, hey, I'm sending over num1 and num2. That gets saved into x and y. Even if I swap x and y, most people would say, hey, it won't affect num1 and num2. But the reason why you're comfortable with that is because you see it as two different variables. So of course it won't affect them. But it doesn't matter if we call it x and y. If I called it num1 and num2, the takeaway that we need to understand is that this num1 right here is different than this num1. Why is it different? Because it's being declared inside a different method. Therefore, it is a different variable entirely. And it actually gets more nuanced than that when we can declare variables in just different blocks of code within the same method, and we'll talk about that very shortly. So that covers this. We've covered that. Activation record for swap, we've covered that. So modularizing code. What is this idea of modularizing code? So if I ask you, well, what is a module? So sometimes textbooks will have chapters, other times textbooks will have modules. So what is a module? It's a subgroup of a larger entity. So you have a chapter in your book, or you could have modules in your book, maybe 8 modules. Imagine if your textbook had no chapters, no modules, and it just went 600 pages from page 1 to page 600. That would be a disaster, right? By breaking it up into modules, it's easier, more palatable to consume. So in the same way, we want our programs to be broken up into these logical blocks that make it easier to maintain, easier to read, easier to what's a good word to say here? Easier to maintain, easier to read, easier to just work with. That's probably a better word I could use there. But this is the idea of modularizing code, right? So new programmers, you'll often see, even if it's a huge program, you'll see 1,000 lines, maybe not a single method. If it's Python, not a single function, just boom, 1,000 lines. That's a disaster. When you can write that same program, maybe with 9, 10, 11, 12 functions, and now it's easier to manage. It makes sense. We can look at your main function. That main function maybe has 80 lines of code that's calling all kinds of other different functions to perform individual separate tasks. That makes it easier to read and to manage. This is the idea of modularizing the code. And the added value as well is it makes it easier to debug, much easier to debug. So here's an example that I'm not going to code live. It's a straightforward example of GCD. We've coded this previously to find the greatest common factor or the greatest common divisor. We've done that previously, but now the purpose of this example is if we offload that code from our main and we then put it in a method, look at how much cleaner this is. Here's our main. We ask the user for an integer. We ask them for a second integer. We print the greatest common divisor or the greatest common factor for N1 and N2 is, and then we just print it and we call that particular method. And here's the method. So why is this a better solution than not having modularized code? But why is it better than if we didn't have any method at all? Well, there's many benefits here. Number one, I would absolutely argue it makes it cleaner, easier to read when we have multiple methods instead of just one huge main method. But number two, it makes debugging so much easier. Because now, if there's an issue with the GCD, if there's an error somehow in calculating the GCD, that error is going to be isolated to that GCD method. right? You can focus strictly on isolating that error, debug it, fix it. It's isolated to that particular module, to that particular method. That's a huge win and value proposition of isolating the computation of the GCD and any errors that may happen from the rest of the program. So now the errors are limited to that method. Additionally, if you then make this GCD as a method, you could use it in later programs. Maybe you work on a program later and you're like, oh, I made a method to do this in some other program. Well, you can just grab that method out, paste it into your program, and immediately start using that method. That is the value. I'm looking at the time. We're at 30 minutes, and we are going to truck through this. Method overloading. What is this idea of method overloading? When you have multiple methods with the same name, this is method overloading. But you can't run multiple methods with the same name if the parameters are identical. So if you have the same name and each method has 3 parameters and they're all integers, that wouldn't work. That actually would give you an error. But method overloading is when you have the same name but different signatures. And remember, what is the method signature? It's the combination of the name with the list of 0 or more parameters. So as long as that method signature is different, we can have multiple methods with the exact same name, all within one program, and that is called method overloading. So we're going to go through an example where we have 3 max methods. One of the max methods will take 2 integers, one of them will take 2 doubles, and then the third one will take 3 doubles. All methods will be called method max, and the compiler will understand which one we're trying to call based off of its examination of the parameters. So if we call method max with 2 integers, for example, Java will recognize that we're looking to call the method that has 2 integer formal parameters. If we send over 2 doubles, Java will recognize, oh, we must be looking to call the method max that has 2 doubles. And same thing if we call the one with 3 doubles. So here I want to show an example. I say, let's test this method overloading program. I want to come up to NetBeans, and here we have this example. So notice we have 3 methods. They're all called method max. We have this first one. It receives 2 integers. It merely determines which is the maximum of those 2 integers, num1 or num2. It returns it. We've seen this particular method. Here we have that exact same method, but instead of receiving 2 integers, it receives 2 doubles. Does the exact same thing. It returns the greater of those 2 numbers. This one's kind of interesting. This method max, also called method max, it takes in 3 parameters. And look at what it does. It's kind of cool the way it works. Imagine if I get rid of this right here. And I just call that num1 comma num3. What is it returning? It's returning the max of this thing and this thing, right? Those 2 things. Well, check out what I had. Instead of this first thing being just a number, I let that first thing be, I'm going to paste right now, its own call to max with num1 and num2. So this first thing, this entire first thing that I'm highlighting, we're going to send over, we're going to call method max, we're going to send over num1 and num2, and it's going to call this particular method right here. Let's say that num1 was the greater of those 2 numbers. Num1 would get returned, and all of this right here would become num1. Or if num2 was the greater of those 2 numbers, all of this would get replaced with num2, and then finally we'll then call the max of num2 and num3. A unique usage of how to get the max of 3 numbers instead of just 2 numbers. That's not the point of this problem. The point of this problem is simply this one, that we have those 3 methods, and Java will determine when we run this, Java will determine which method to use. When I call max of 3, 4, Java is not going to call this one, because what do I have here? I have 2 integer parameters. Java sees, well, I got 3 methods that all say max. Here, this method has 2 integers for parameters. This has 2 doubles for parameters. This has 3 doubles. So method overloading is this idea that Java, we can use the same name for all those methods, and Java will determine which one it should call based off of an examination of those parameters. So here clearly I'm calling the first method. Here clearly I'm calling the method with 2 doubles, the second method. And then here I'm calling this third method that has 3 doubles. This is the overall idea of method overloading. Now with method overloading comes ambiguous invocation. What is ambiguous invocation? Well, first thing, what is ambiguous? Ambiguous means it's not clear, right? So what is an example of ambiguous invocation? Is when you're trying to perform method overloading, but it's no longer clear to Java which of the 2 methods you're intending to call. So hypothetically, what if I got rid of all of this? I'll code this one up live. Just the example itself. Let me get rid of that, get rid of this. Let me I'm going to copy this method. And let's notice that it immediately made it as an error, right? Because now this is not method overloading, this is called method error. Because here I have 2 methods with the exact same name and exact same signature. That's not allowed. What does it say? It says method max with int is already defined. But if I make one of these double, then of course I have to return this as a double possibly, then it's no problem, right? That works just fine because now this is a different method. Let me even make one more. Let me do this. And I'll make this first one an integer. And I'll make this second value a double. So now we have num1, num2, they're both integers. Then we have 2 parameters, a double followed by an integer. And now we have 2 parameters, an integer followed by a double. Okay, what is ambiguous invocation? We'll check this out. Right now, if I said print the max of, and I send over 2, 3, what's going to happen? Do I have an extra? There we go. If I print out the max of 2, 3, there's no problem because I'm sending over 2 integers. Java's going to look above and it's going to say, well, where should 2 integers go? I have a method max with 2 integers, a method max with a double followed by an integer, and a method max with an int followed by a double. So clearly it can see which one goes. There's no ambiguity, no problem. And it's going to use this first method right here, right? I'll even type this in here just so you can see the output, run it. It's going to use that first method and it's going to print out, of course, 3 is the maximum of those 2 numbers. Now watch what happens. When I delete this, what's going to happen here? And for clarity, let me delete this one as well. It doesn't matter which I delete. I'll delete the second one. Right now, there's no problem. I'm calling method max, and Java is going to try to see, do I have an appropriate method? Well, I have 2 parameters. Here's method max with 2 parameters. I am sending over 2 integers. And what are the listing of these formal parameters here within the signature? The first parameter is expecting a double. The second parameter is expecting an integer. So I have a double followed by an integer. I want to send over an integer followed by an integer. Is that allowed? Yeah, it's allowed. We can send an integer to a double. No harm, no foul. We can send an integer, of course, to an integer. You can't send a double to an integer without explicit casting. But here, without explicit casting, I can absolutely send an integer and save it into a variable of type double. So that works just fine. So what is this idea of now ambiguous invocation? Well, right now we have this method max 2, 3, and Java's trying to determine which of these 2 methods should be used. I have 2 parameters, an integer followed by an integer, my actual parameters. I can call this method, which is a double followed by an integer, or I can call this method, which is an integer followed by a double. Neither is better, right? And so when you put your mouse over here, it's going to say reference to max is ambiguous. Java cannot determine which one should be used. If I were to have made this 3.0, now it's clear. oh, you must want to call the method that has an integer followed by a double. Or if I made this 2.0 or 2.2, Java realizes, oh, you're calling this method, right? But when they're both integers, and when these two methods are equally, by their method header, can equally suffice calling with this method, this call to method max, Java's like, yeah, I don't know which one you want. Which one do you want me to call? I don't know. It's unclear. It is ambiguous. I hope that's enough to explain ambiguous invocation. This is that same particular example here on the slide. Final thing is scope, and then we're done. We talked about scope somewhat, not extensively though. We talked about scope. Scope is the area of your program where a variable is understood. Where's your variable understood? We defined it previously. It's understood from its declaration, as you see here. I'll just make this an int. It's understood from its declaration until the end of the block of code that it is defined inside. So here, it's understood starting on line 10. The scope of X is from line 10 all the way to the end of the block that it is defined inside. X is defined inside this block. Look for the curly bracket. X is defined within this main method. All the way to line 21 is the scope of X. Now, what if I have a for loop? And we have some other print statements in here. I'll put one more. What is the scope of this variable I? Well, the scope is from where it's declared, which is right here. It's declared inside the actual syntax of the for loop, so on line 13, all the way until the end of the block it's declared in. So it's part of the for loop, so the scope of I ends right here on line 17. If I were to print right here, I, it gives me an error. And in fact, when we read it, it says, sorry, I'm trying to put my mouse over it, cannot find symbol variable I. It doesn't understand what I is. Or maybe a better example would be, or a different example, what if I were to make int y equals 5? And I do other stuff with y. I say y plus plus. Maybe I print y. We print y. All that's fine, right? But what if I want to print y right here? What's going to happen? Java's going to say, yeah, I don't know what y is. It says cannot find symbol y because y is only understood, any variable is only understood within its scope. And what is the scope of a variable that we've learned until now? It's from the line that it's declared on until the end of the block that it was declared within. Even if you have just a useless block, if I get rid of this for loop and I just say, you know what, I'm just going to make a block of code. No one does this, but it's allowed. You can make just a block of code. Here's just a block. We have an opening curly bracket. We have a closing curly bracket. We made y within that block of code, so therefore its scope finishes here on line 20, which means on line 22, we cannot access y. We can no longer access it because we're outside of the scope of y. That's what we've discussed previously. It was important to give that reminder. So now what about the scope of local variables? And a reminder, what are local variables? A local variable refers to any variable that is defined inside a method, as well as the formal parameters. Those are considered local variables as well. So what is the scope of a local variable? The scope of a local variable begins from where it was declared within that method until the end of the block of code that contains that variable. Now, if it wasn't declared within a particular block in the method, then the scope would be for the entirety of the method from where it was declared. But maybe inside the method you're in an if statement or you're in a loop of sorts and you make a variable there, well, the scope would only be until the end of that block. And of course, like any variable, a local variable can only be used after it has both been declared and assigned some initial value. So parameters are local variables. A parameter is declared where? Inside that signature. That means the scope of a parameter is for the entire method, right? The scope of the parameter is for the entire method in the same way that the scope of this variable I is for the entire for loop. The scope of some other variable of a method, public static void scope example, int w. Well, this integer w is going to be understood for the entirety of this method. If you had all kinds of stuff here, the scope of w would be from line 32 all the way to line 42. That would be the scope of that particular variable. So we'll end with just some examples here. Here we have void method 1. The scope of I is for the entirety of this for loop. So it starts right here on this curly bracket, and the scope of I ends with this curly bracket. The scope of j is from where it was declared all the way until the end of the block that it was declared inside, which is also this curly bracket. You can declare a local variable with the same name in different blocks within a method. Is that weird? Let's see. We've seen this already, but I'll show it again. Let me get rid of this method. We come to our main method. Sure, if I make a for loop, let me delete all of this. If I make a for loop, and then after that for loop is done, I make another for loop. Notice, by default, NetBeans used I as our indexing variable for this for loop, and it redeclared I for this indexing variable, which is okay. Why is that okay? Because this int I was declared here, and its scope ends on line 12. So when I make another for loop outside of that loop, absolutely I can reuse I. Now, compare that to if I make a for loop here within or inside this for loop, so I make it nested. Now NetBeans uses a different variable. Or here, if I were just to make my own empty block for no reason, or useless block as I call it for no reason, I'm going to set int x equals 5. And then after that block of code, I can make a brand new block, and I can say int x equals 8. I've declared two independent x variables. Why was that allowed? Because this x variable right here, its scope began on line 11, but it ended on line 12 as soon as that curly bracket was encountered. So therefore, I don't even need the curly bracket. I'm just showing you that here, now I can just say int x equals 8, and this is a different variable because the scope of this variable has already concluded on line 12. Kind of funky. Again, you would never really do this by putting this declaration inside brackets like that, but it's just to show you that the scope of a variable is only within its block of code that it was declared within. So once that block of code completes here in line 12, that variable is no longer understood within the program, and you can redeclare it as you see on line 14. And that's about it, right? We have one more example here with the two for loops that I just showed you, and then on this one, so here we have int I was declared twice. That's okay. And here it says it's wrong to declare I in two nested blocks. So I could not declare I above and then redeclare I here in this for loop. So I'll type that one. So if I were to say int I equals, let me do it this way. And then above here, if I were to say int I equals 8, well, Java's going to say, well, if this I equals 8, the scope starts on line 10, and where does it end? It ends at the end of the block it was declared inside. So it was declared where? Within main. Where's the end of main? Right here. So all of this area represents the scope of I. You cannot redeclare a variable I within that area. Yet we tried to right here. That's an error. So we'd have to come over here and rename I within this for loop, or rename this to something else to get rid of that error. So I'm looking at the time. We're over time. I wanted to do 45 minutes. I have an example here. It's something we don't have to go code through. It was just a problem from the book of printing all Emirps, which is, most people would say and should say, what is an Emirp? It's basically a prime number backwards. So it's Emirp is literally prime spelled backwards, and it's a prime number that, an Emirp is a prime number that results in a different prime number when its digits are reversed. So 13 is prime, its reverse is 31, that's also prime. 37 is prime, its reverse is 73, that's also prime, therefore it's an Emirp. An Emirp cannot be a palindrome though. So 7 is prime, its reverse is prime, but it's the same number, it's a palindrome, therefore it's not an Emirp. Kind of a weird problem, but it's a good one to practice modularization because we need to make an is prime method, we need to make an is palindrome method, and we need to even have maybe a reverse number method to reverse those numbers to then check before we can check if its reverse is prime. So it's a great problem to practice all of those things. I'm going to very quickly not even explain the solution because I'm already over time, but I want to show it in case anyone wants to look at what I did and pause the video. Here is an is prime method I used. Here's a reverse number method I used, which is silly, but I didn't want to do the mathematical way. I wanted to use it as a string. I figured it'd be easier for most listeners to consume. Here is an is palindrome method that we've shown previously, also using just strings, easier to understand. And then finally, here's our main. I wanted to go print out 120 Emirps. I did a while true, and I simply said, if this candidate number is an Emirp, if it's prime, I said, and it's not a palindrome, and if its reverse is prime. So I called the reverse of that particular candidate number. I got its reverse. So imagine I'm at 17, so I get 71, and I check, is that also prime? So is 17 prime right here? This is checking, is 71 prime? This is checking to make sure that it's not a palindrome. And if all of that is true, boom. I found the new one, we print it, and we update our account. And if I run this code, we get the first 120 Emirps printed to the tune of 10 per line. Not going to explain more than that. Feel free to reach out, leave a comment, ask questions. But that's it. That wasn't too bad. As always, comment, ask questions if you need anything. It's been fun.